So the second part of today's lesson is just a little review. And it's a mixed review, spirals back to some concepts that we had talked about before. So let's take a look at it. First problem will ask you to graph the function. Remember, a function is when the x values only have one range value. Domains only have one range. And so you can see that it passes what we call a vertical line test. So if you pass a vertical line through, you'll only end up with the graph crossing that vertical line just one time. So here's an example. Positive 2. This is called our y-intercept. So we're going to go up 2 spaces on the graph and put the dot right there. We call that the y-intercept because if you cancel out the x term, make that equal to 0, y equals 2. And see, we don't go over any spaces on the x-axis for the y-intercept, just go up to that point. Well, the slope of this line is 1 to 2. So, 1 to 2. So that tells me I'm going to end up going up 1 and then right 2 spaces. So from that point, I can go up 1 space and right 2, and I end up right on that same line every single time. That's why when we talk about lines, they have consistent rate of change. The rate of change is the slope. See, it's changing by going down to the left or up to the right. And that's what's neat about these equations, is they're always the same. The rate of change will always be the same when we're dealing with a line. And the rate of change is the slope of that line. So there it is. I'll just put some arrows at the end showing that it goes on forever. Here's another example. We've got the y-intercept here of negative 4. It says minus 4. So that's where we start this line. You always need a starting point, and that's what we're doing here, going down 4 spaces, putting a dot. Then we use the slope. Now the slope of this line is 3 to 1. So that 3 tells me I'm going to end up going up 3 spaces and right 1 space. So again, from that starting point, I'm going up 3 spaces, 1, 2, 3, and over 1 to the right. Up 3, 1, 2, 3, over 1 to the right. And I can do that a number of times and be right on that line. I could also go the other way, which is down 3, left 1. And then I've got some points in which I can draw a line through. So, nice thing about this method, it gives us lots of points, so we can draw a nice straight line. Well, that's the first type of problem. The other 3 problems are like the ones down below. They'll ask us to write an equation in slope-intercept form given the slope and a point. So these are problems similar to what you did when you wrote equations that are parallel to a given line. However, this time they give us the slope. So we don't need to find the slope. It's given to us. All we have to do is use point slope. So point slope is that y minus y1 equals m times x minus x1. You take the slope, 2, you put that in for m. You take the 3, which is x, you put that in for x1. You take the negative 4, which is y, that goes in for y1. And then we simplify. So what we've got is this. We've got y minus negative 4 equals 2 times by x minus 3. So whenever we have that minus negative, just change that over right away to plus positive. And then distribute the 2 over that subtraction. So now let's see what we've got next. We've got this y plus 4 equals 2x minus 6. So from that point, all we have is just one step. Just need to move this 4 over by doing an opposite operation. This is a plus 4, so I'm going to take 4 away from both sides. Notice those are the same sign, so I need to add those 2 numbers together. And what do I have left? Well, this is what it is. Y equals 2x minus 10. There's our answer. So in the slope-intercept form. The nice thing about this is now you understand how to graph this It's got the negative 10 for the y-intercept. Slope is 2. So having an equation is powerful because from there we understand what the graph of it looks like. So now, here's another example. We've got the slope. We've got a point. We're going to use this familiar point-slope form of an equation and substitute those given numbers into our equation here. So we've got negative 2/3. That goes in place of m. 6 goes in place of x1. Negative 1 goes all the way over here in place of y1. So we go ahead and do that substitution. We've got a y minus negative 1 equals the slope, which is negative 2/3, times by x minus, and then I write down 6. Well, from here we need to use that distributive property. Multiply this negative 2/3 over that subtraction, and then also, whenever we have that minus negative, let's add the opposite. So our next step is just to rewrite, let me erase that part. We'll rewrite that y plus 1 equals negative 2/3 x, and then the two negatives cancel out. So let's take a look at this. Negative 2/3 times negative 6 over 1. Now again, I treat that as negative 6 because whenever you have a minus problem, you can change it to plus a negative. So you can think of that as like negative 6 over 1. Well, when we go ahead and do the reducing, let's see what happens. 3 goes into 6 2 times. So go ahead and multiply the 2 times the negative 2, and that gives me a positive 4. So positive 4 is what we end up with there. Well, from that point, just need to move this plus 1 over. So I'm going to do the opposite operation again. Subtract that from all sides, and we'll have our answer. So we're going to end up with y equals negative 2/3 x plus 3. There is our answer in the slope intercept